Welcome to this video on drawing electron configurations. Before we start, we just need to remind ourselves that electrons are arranged in shells around the nucleus. So we've got the shells on the outside here, and the electrons are moving around the nucleus on them, and we've got the nucleus in the center with protons and neutrons. Now, when drawing electron configurations, the nucleus is replaced by the element symbol. So the nucleus here is going to be replaced with an O, which is the symbol for oxygen, because we have an oxygen atom here. There are 4 rules that we need to remember when we draw electron configurations. The first shell holds up to 2 electrons, the second shell holds up to 8 electrons, the third shell also holds up to 8 electrons, and when we draw electron configurations, we start filling the inner shells first, and then we work our way outwards. So we're going to start with the example of carbon. Now, before we can draw the electron configuration, we need to know how many electrons carbon has. In order to know that, we need to know what the atomic number of carbon is. So what is the atomic number of carbon? The atomic number of carbon is 6, and that means that carbon has 6 protons and 6 electrons. So to start drawing the electron configuration of carbon, we put the symbol in the middle. The symbol of carbon is C. Then we continue by drawing the first shell. Now we need to remember the rules we talked about before. How many electrons can be put into the first shell? 2. So it's 2 electrons that we put into the first shell. Now you can choose if you want to represent the electrons with crosses like I did, or what you could also do is you could use little dots, but I'm going to use crosses as we continue. So we've got 2 electrons in place. As we draw the electrons, we try to put them as far away from each other as possible, as you can see here. So how many electrons do we have left now? It's 4. So 4 electrons are still left. So we need to draw a second shell, and we're going to put the 4 electrons that we have left into the second shell. Again, we are going to put them as far away from each other as possible. Now we have used all of the 6 electrons, and we have drawn the electron configuration of carbon. There is the possibility to write this entire drawing in a shorthand. Okay, and the shorthand starts with a 2, because there are 2 electrons in the first shell, and then we put a comma and a 4, and the 4 we put because there are 4 electrons in the second shell, and that is the shorthand for the electron configuration of carbon. Now we're going to look at a second example, and that is sodium. Again, to be able to draw the electron configuration, we need to know how many electrons sodium has. And for that, we need to know the atomic number. So what is the atomic number of sodium? It is 11. Okay, and that means that sodium has 11 protons and 11 electrons. So our electron configuration for sodium now will have 11 electrons. And how did we start? Again, we are going to start by putting the symbol in the middle, which is Na, and then we're going to draw the first shell. How many electrons did we have in the first shell? 2 electrons. So again, we're going to put those electrons as far away from each other as possible. And now, how many electrons do we have left? It's 9. We still have 9 electrons left, so we are going to draw the second shell and try to remember how many electrons could we put in the second shell. 8. It's 8 electrons that we can put in the second shell. So we're going to start filling up the second shell. And again, we're going to start by putting the electrons as far away from each other as possible. So now I've got 6 electrons. I've only got 4 electrons in the second shell so far. So I have 4 more that I can put in. After we've put 4 electrons, we start pairing them up. And we always put one next to one electron that is already there. So as we continue, the last 4 electrons in the second shell we're going to put next to electrons that are already there. So now in this electron configuration, I have 10 electrons. How many electrons are left then? There's still 1 electron left that we haven't drawn, so we need to draw the third shell. How many electrons could I put in the third shell? I could put 8 in total, but we only have 1 electron left, so we're just going to put this 1 electron that is still missing for sodium. Again, we can write this in a shorthand version. So we are going to start again with a 2 for the first shell, which holds 2 electrons. Then we have an 8 because there are 8 electrons in the second shell, and the last number is a 1 because there's only 1 electron in the third shell. So 2, 8, 1 is the shorthand for the electron configuration of sodium. Now you are going to have a go at fluorine. So grab a piece of paper, pause the video, and first of all, just think about how many electrons does fluorine have. Fluorine has 9 electrons because its atomic number is 9. Now, pause the video again and take some time to draw the electron configuration of fluorine before you check with the video. To draw the electron configuration of fluorine, again we start with the symbol in the middle, which is F. We draw the first shell. The first shell has 2 electrons. 9 minus 2 makes 7, so we've got 7 electrons left. We start with the first 4 electrons, put them as far away from each other as possible. And then we have 3 electrons left that also go into the second shell. Again, we can write this as a shorthand. So again, stop the video and think about what would the shorthand be for the electron configuration of fluorine. The electron configuration shorthand for fluorine would be 2, 7, because we have 2 electrons in the first shell and 7 electrons in the second shell.